In this chapter, we're going to discuss multiple linear regression. So the topics that we will cover in this chapter include explanatory versus predictive modeling, looking at what they are and what the differences are. And we'll be using an example data set, prices of Toyota Corollas. Now we're going to look at how to fit a predictive model, how to assess the model accuracy, and then how to select important variables, because data sets sometimes will have lots of predictive variables, X variables, and we want to select a subset of those X variables because more variables will make the model more complex, and more complex models are difficult to maintain and use. So these are the topics that we're going to be discussing. So a typical multiple regression model would look like this, where you have a target variable, or sometimes called response variable, and we denote that with the symbol y. And then we have a constant coefficient, this is called the intercept, beta sub 0, and then a linear combination of the predictor variables. So we have p predictor variables, x sub 1, x sub 2 through x sub p, and we have slope coefficients for each of the predictor variables going from beta sub 1 through beta sub p. Okay. And then there is a error variable. So each value of y, then we are assuming, is determined by a constant. When you plug in the x values, you get a constant value here for that combination of x's, and then there is a random error, and that sum will give you y. So this part is the mean of y given a set of x variables. And in the course of regression modeling, we will come up with an estimate of these coefficients. So these coefficients, beta sub 0 through beta sub p, are unknown because they are for the population. So we don't know what values are for those coefficients, but using the data that we have taken from the population, we're going to try to estimate the best possible values for these beta coefficients. So the beta coefficients, the Greek letters, are for the population parameters which are unknown, and then we use corresponding variables called b sub 0, b sub 1. These are values that we calculate from the sample, or estimates of these beta coefficients. So that's what we're going to be doing, at least in the first part of this chapter. Okay, now let's look at some general concepts. So in a regression modeling project, okay, what would we do? You know, we have a data set and we know what the target y variable is. So now, are all the variables to be included in the analysis, or only some variables? So choosing which input variables to include. Some variables may have no predictive ability or predictive value with respect to the y. So that's one thing that we have to consider. And once we have selected input variables, and we have some choices to make. Should we use the input variables just as is? So some numerical variables will have good properties, like no skew, evenly distributed, and there are no outliers. So then you can use those variables as is. But if you have some issues, like if it is skewed to the right or to the left, then you have to do some transformations to make it less skewed. And we can do transformations like logarithm of x, or we have what are called box-Cox transformations, where you take the variable and then figure out what kind of power you should raise it to. Like you can make x squared, or x to the power of 3, or 1 over x, or 1 over x squared. So there are a whole slew of box-Cox transformations that are possible, And there are statistical packages which will go through all those different possibilities and select the one that lessens the skew the most, okay, the one that will make it as much symmetric as possible. And then we have, if you have categorical variables, and those categorical variables will have to be converted into numerical dummy variables. Dummy variables are binary variables. They can take only values zeros or one, and we will talk about that. So we have to do some transformations like that. And then there are some times that we may want to take a numerical variable and bin them into classes, okay, and then have dummy variables for those classes. Okay, sometimes that may be preferable, so you may consider binning a continuous variables into a categorical variable. Then once we have done all that, then choosing the right form of the relationship between the input variables and the y. Okay, what kind of relationship? Like that one. Okay, so maybe some variables will have to be squared. Maybe some variables will have to do a reciprocal, things like that. What kind of relationship should we set up as our model? And for that, choosing the right form, okay, depends upon domain knowledge and availability of data. Okay, so so these are the things that we have to do for model preparation. Okay. And then actually we start estimating the coefficients b sub 0 through b sub p, and then once we have the coefficients estimated, then we can use those coefficients to making predictions with new cases.